false, we can go over it next. But if that were true, like you said, how do we handle it? So for to allow that's one of the changes. One is to be able to change the bucket data itself, and two is to allow the user to do it. So self-service plus mutation, those are the two things. So the reason it was hard to do with the existing model is because if we were to mutate, well, one is because only the admin can do it, because BR cannot do that as it is now. And two, if we were to allow mutation on any one bucket, when we do share that bucket, we end up in a situation where one bucket has current data and the others don't.
Well, hold on. One of the problems you mentioned, which is the self-service, is a non-problem because as long as buckets, requests, and buckets are bidirectionally bound, you just have a controller that propagates the changes directly from the bucket request to the bucket, and you're done. The problem is once it ends up on the bucket, you have the same problem as if the administrator did it, which is, what's the source of truth?
Yeah.
The self-service aspect of it is not a problem. It's just the lack of source of truth that's the problem. Sure.
You're saying that because you can always have the parameters come from the bucket request, we can also use that to change.
If they're bound one-to-one, then it's unambiguous what you should do.
So they are bound one-to-one. BR to.
You have many one-to-one, right? So that's still a problem, right? Which one?
Right. For an individual bucket request, it's obvious what to do. The problem is when the bucket gets updated and there's multiple buckets that map to an actual bucket, then it's not obvious what to do.
Yeah. So one of the approaches we talked about that will actually address a bunch of problems that we've been facing. So one of the reasons we came up with an approach, that the approach that we have today, is because we wanted to avoid any manual steps or admin related steps in the process. But then when we concluded the design, we ended up using it anyways. We ended up having a admin related step anyways.
I don't agree with that.
We do have it. Bucket class is created by the admin.
Right, but if the bucket class had the mutation policy set to true, and you go create your bucket, then your bucket is going to have mutation policy set to true, and you're welcome to go mutate that bucket, and your changes will be reflected.
No, I was talking about the fact that admin has to be a part of the process.
No, but only once up front when they create their bucket class, which is that then they always have to be involved in creation of the bucket class. So like there's just a different decision they have to make up front to say allow mutations.
But who makes the mutation?
Then the end user.
On the bucket object directly?
No, on the bucket request. And then you have a controller that reflects changes in the bucket request to the bucket. And then if the bucket also has a mutation policy that's set to true, then you go realize that change.
So here is the reason we can't have bucket requests have these parameters. If we do that, then it's going to contend with the parameters in bucket class. And it's tricky to figure out who wins this. Like, let's say both of them are setting a particular parameter. Which parameter gets honored here? And is it the same for all fields? But we don't have to go down that route.
But my argument would be for these things that are going to be represented as first class objects in the API, they shouldn't be in the storage class. They should always be on the bucket requests, and then you just always set it on the bucket request, and you always get what you want. If it's meant to be something that you can do self-service, then it should never have been on the storage class. That's the whole thing. The storage class is the stuff that is sort of the prefix menu that the chef made, and you get to choose off that menu, and you don't get self-service. You can't make changes to the prefix menu.
Agreed.
But for the things you do get to change, that's what your bucket request is for. You put all the things on the bucket request.
Yeah. So it's good that you brought it up. So if you go through the list of things that are configurable, and let's first define what an application developer is. Like, the person who's requesting for a bucket is someone who's concerned with how their application works, whose job is to work on their specific application. Now there are obviously outliers, people who do everything, but that's more the exception than the rule. So if we were to consider what an application developer cares about, they care about having a bucket for the application, and they do not care about things like logging access logs on the bucket, or versioning of objects in the bucket. Those are more infrastructure level concerns that are generally set either organization wide, or team wide, or some sub department wide, whatever. Um, when we go through all the list of configurable features, I can't find one that an application developer should care about.
I mean, I kind of agree with that,
Mm-hmm.
but like other people keep saying, no, anonymous access is one that you need to twiddle, and
Mm-hmm.
object locking is one that you need to twiddle.
An application developer, let me put it in even different way. We're actually making things more complex by allowing this. Like if you see, one of the reasons why a good example is like how no I'm trying to form my thoughts here.
Can I take a swing?
Yeah, go ahead.
So like the reason something like object locking enabled matters is if my application is designed around the assumption that it's going to be able to lock objects because it can't function correctly otherwise, and like I install this on a particular Kubernetes cluster and it works. When I take the same application and install it on a different Kubernetes cluster, it better work exactly the same, or I've lost portability, right? So like,
We're not saying
if
it's not configurable. So you can still configure these options while creating the bucket. We're just saying the user should not care about mutating these things. There's an even more important reason why the user should not do it. The user doesn't have any visibility into how other namespaces use the bucket, which applications use the bucket. If a user can go and mutate these policies, and let's say a different application was relying on one of these parameters, now you are actually, uh, you know, allowing a scenario where blind changes are made to the bucket, and can affect the other workloads in a way we don't understand.
but if the case I'm concerned about is if the underlying storage system doesn't support object level locking,
Mm-hmm.
and I try to run my application on that particular Kubernetes cluster where that particular driver and storage system is installed,
Mm-hmm.
it's not going to work well, right? Because my pod, I'll get the bucket, my pod will start up, my pod will begin making object lock requests through whatever the cozy standard way that we say you should do that is, and
Yeah.
and they're going to fail because the guy on the other end doesn't know what you're talking about, and like you want to have a way of formally saying like this bucket I'm asking for needs to have this feature that I'm going to depend on, and then if the cloud can't do it, like or maybe the cloud has two different storage systems and it's got to pick the one that can do it. I mean, those kinds of things, if the workload
if you look at,
will work or not work depending on whether the feature is present, then it feels like it needs to bubble up all the way to the top, assuming that it's not like some proprietary thing that only one vendor supports, right? It would have to be something that would be supported across the industry.
Right. Exactly. Yeah. This is the list on the left. So coming back to that, if we were, let me think about this. So what was I thinking? I had a really good point here. Okay. Anyways, so if we were to look at these options right in front of us, none of them. This is what I was thinking about. So an application works with the data APIs. An application almost never cares about configurations or the provisioning level options. That's where I'm coming from when I say again, I'm going back to this idea that these are fields that application developers should not care about. They shouldn't even know.
Yeah. For a lot of them, I agree. I
You're
worry
saying there
there's,
might be one that is important, like without which an application cannot work, correct?
well, no, just that. So we had this discussion, I don't know, months ago, down at the cozy level, where we're talking about, you know, what goes in the, you know, what's parameters and what's first level, you know, API fields,
Mm-hmm.
you know, like what's an opaque string map and what's a first level field. And the
Yeah.
argument was, if it's something that's supported by multiple vendors and we want to standardize it, that's when it gets promoted. And the reason you do that is because it has to flow all the way through the API from the user saying, I want this, all the way through to the downward facing part where the pod says, I got the thing that I asked for.
Mm-hmm.
And it's because it changes what the pod can or cannot do.
Yeah.
And we have to have verbiage in the spec that says, if like feature X is turned on, like this is how you use it.
Mm-hmm.
Because if we don't put that in the spec, then it's the Wild West, right? Anyone can do anything.
Mm-hmm.
So like, and I don't know if object level locking is the thing that will, you know, be an example of this or not, but it feels like one to me, because it's, who's going to use it if not the application running in the pod?
Oh, object level locking is more. I would think it's still application level, because what you're saying is an object cannot be deleted, that or overwritten. Um, I mean,
But that's something the application requests, right? He says, I'm going to make an object, I'm going to lock this one, I'm going to make another object, and I'm
oh
not
no,
going to
it's not
lock
per
that one.
object. No, it's not per object. It's a bucket level feature where if you say this bucket is object locked, then all the objects in that bucket become they call it worm buckets. Write ones, read many.
Oh, so then
Yeah, they call it object level locking, but it's not per object.
it's not actually locking, it's worm. That's what it
Yeah,
is.
yeah.
Oh. Still might be relevant to an application. Um, if only, well, okay, I can start to see how that's not relevant to an application, because yeah, like if you happen to accidentally get worm when you didn't want it, of
Mm-hmm.
course your application is going to blow up.
Mm-hmm.
But if you wanted worm and you didn't get it, then you just don't have your worm, but everything works fine.
Yeah.
So, okay.
Yeah, these are all bucket level policies.
Okay.
I mean, there are some that are obviously not something an application should care about, like replication, access logging. Um,
Yeah.
Lifecycle is more like object lifecycle management. Um,
How about the anonymous
but,
access one that people keep bringing up? I forget who likes to harp on that one.
I think that's like
Is it Jeff?
not Jeff. I think it's like Tim and Andrew.
Okay.
Yeah.
I mean, there was this theoretical
I
workflow
think
in which
but yeah, go ahead.
where you want to create a bucket that's initially not public, and you want to run some workloads to sort of fill it up.
Yeah.
Then
Yeah.
after it's filled up, you want to flip it to public,
Mm-hmm.
so that people, I guess, outside the Kubernetes cluster can start to use it. And
Mm-hmm.
yeah, like
So yeah, I was thinking through that. Uh, Something like that you do on a you're talking about a manual operation at there. Um, Either you don't go through Cozy for a bucket like that, but if you have workloads that are going to fill up something like that, the switching is still manual. It's not like the workload decides to do that. I can't think of a scenario where that needs to be automated.
yeah, me neither. I mean, well, the scenario where it needs to be automated already goes outside of Kubernetes.
Yeah.
And once you've stepped outside of Kubernetes, it seems perfectly reasonable to say, just go flip the switch on the bucket yourself,
Right.
because you're already not in Kubernetes anymore.
Mm-hmm.
And to be clear, like, even if it's a greenfield bucket, you can still find the actual bucket
Mm-hmm.
through Kubernetes, right? It'll tell you how to go to the actual management plane for that cloud provider and go flip the bits you want.
Mm-hmm.
So yeah, I am on board with that. Say
Mm-hmm.
you do that outside Kubernetes.
Yeah, exactly. Bucket tagging again, similar to that. you put tags on the bucket to be able to filter it and all that. Um, I need to figure out what bucket. This might be. I don't know what this policy is. Oh, another thing about coming back to anonymous access. There is a more important thing about anonymous access. Anonymous access is a deprecating feature. So people don't want us to use anonymous access at all. It is actually a security. It's easy to get into security loopholes or vulnerabilities using this. So it's a ACL really for the entire bucket. Um, and AWS supports what three types of authentication like ACLs and IAM and like simple token service. Um, AWS wants us to stop using the ACLs. ACLs are just by design, like a catch-all kind of access policy and or access control. Um, and the lack of granularity makes it really easy for someone to assume that say let's say a particular subdirectory was made private but another was made public. It's very easy to go wrong with it, like, and AWS is actively discouraging the use of ACLs. I can show you right now.
But there is the concept of like a bucket that's open to the world, which is like my just my like I have a bucket where I'm just publishing blobs on the internet, right? And I'm using S3 to back that. Like that's
Yeah,
a valid use case, right?
yeah.
Where the whole bucket is readable to the whole world.
And that's only for static provisioning. So ideally, like take any database for instance, you have the database always fronted by some kind of application, and the link between the application and the database is private, but then the application is the one that's front facing.
I'm not even talking about an application. I'm talking about people just using buckets as a publishing
Yeah,
platform.
yeah. Buckets as a publishing platform is a very narrow use case, and that use case is for static provisioning.
But like what if I have like a build farm that cranks out builds every night and it just uploads it into the bucket, uploads it into the bucket. So like my automation needs to be able to shove things into the bucket
Mm-hmm.
because the rest of the world is gonna look for web links that pull the blob out of the bucket.
Mm-hmm.
I guess the argument there is like you would never create that bucket through Cozy. You would just have a bucket and then Kubernetes would write stuff into it, but
Mm-hmm.
you wouldn't automate the creation of that bucket.
Mm-hmm. Fair enough.
Which I totally buy because yeah, it's the bucket is necessarily exposed outside Kubernetes, and so why would you create it inside Kubernetes?
Right.
You would create it through the normal way.
Mm-hmm. Exactly, yes. And that's again a manual step.
Where do you
Yeah.
set the anonymous mode? This one is block
Yeah,
all.
so this is AWS.
Uh-huh.
Give it a name. Region is one of the options. Then this is the anonymous access mode.
This is block all. So that's
Block all.
like
By
nobody can.
default is block all.
But if you don't select it, then that's anonymous access now.
Yeah.
Okay.
So acknowledge, and then I say block public access to buckets and objects granted through new access controllers. So once you do this, right, like there's a permanent, like, one of these caution signs that shows up above your bucket saying that there's ACL set on it, start using IAM instead. Even with IAM, you have this policy where you allow access for everyone, but they themselves discourage it. But like Ben was saying, there's that one use case where you do CI/CD builds and then you push it to the buckets.
But it's not I mean, this is how S3 got its start, right? It was people just wanted to publish crap on the internet, and so you would get buckets and do it. Like that's
but if you see
that's why S3 became popular initially,
right.
And then it got all these other use cases added to it over the years, and maybe those became more of their core business. But the whole point originally was I just need a place to push stuff out on the internet.
Right. So this is anonymous access. Then you have versioning. You have tags. It's just for like filtering when you search or whatever. Encryption. We have that here. I mean, we've added that. And then object locking, which is worm, as I was saying earlier, but it's at the bucket level.
Right, and it's not really locking. It's Yeah, that's just a horrible name.
Yeah. Oh, did you think it was like it was like a distributor lock, or did you think?
Yeah. I mean,
Oh, no.
why the hell not?
Yeah,
Like,
I know that would be good. But there are no locking semantics on the object itself.
but there could. I mean, S3 doesn't, but like, there's no reason that a decent object system couldn't. Like the
Sure,
future.
yeah,
The future of object storage is very bright, and
agreed.
like stuff like real object level locking will come someday. You know, bucket level snapshots are coming, or they already exist. You
They
know,
already
we have,
exist.
so like all that stuff is going to be here. We're going to have bucket snapshots to cozy before very long. You
Mhm.
know,
Yeah, absolutely. Um, yeah, absolutely. So, but I think this kind of drives the point again. Looking at the set of configurable options here, um, none of these would be something that an application developer whose core concern is the business logic of their application would care for.
and the portability of their application.
Sure, portability of their application. um, well, that's still not the concern of the application developer. They have to enable it, but the concern belongs to the DevOps person, the admin.
Well, but I mean, like
Who would own it?
it's our job as when we provide the interface that like if somebody consumes our interface in one cloud, and then they go over to another cloud, that they have a reasonable shot at things just working, right? If
Right,
that's not the case, then we have failed.
right, yeah, agreed. I was coming more from the point of whose responsibility would it be within the organization to configure it, and assuming the application has the provisions to do it right, but it needs to be configured. Who would be responsible for doing it? That would be
Okay,
that.
yeah.
Yeah. Yeah. So yeah, like I was saying, so like I think it's fair to make the delineation between provisioning time concerns and access time concerns. Like provisioning time concerns are what we're dealing with here, and access time I would say are the IO APIs like put, get, stuff like that. Um, those things the application truly cares about. That is something we need to allow the application developer to specify. For instance, they might want um, the bucket that they create, they might want to make it write only for a particular directory, or not listable or whatever, and we can configure all of that through the bucket access request. That's the access policy. That's the authenticated access policy. So again, going back to this delineation, calling it provisioning time concerns and like IO APIs. um,
I'm
I
not sure
don't.
I'm comfortable saying that like the bucket access request is the place where we manage access time concerns, because the whole thing about BARs is that you can have lots of them and for all your different workloads.
Mhm.
And like if they have some source of truth in them and they
Oh,
don't agree with each other, then you have more
oh,
problems.
let me. So the access policy applies for the IAM user.
Oh, okay. So you're saying maybe
Yeah.
it would be write only for this workload, but then
Yes.
this other workload, he can see what's in that directory.
Right.
Okay, so then it literally is just like a
Access time.
policy you're setting for that
Access.
connection.
Yeah. Yeah. For that IAM. Yeah. Can be multiple connections, but for that IAM user.
Right.
Yeah. Um, yeah. So
Okay.
so if we looked at it that way, provisioning time versus access time, maybe there's a better way to better words to put it. Um, Again, bucket mutation. So since we only deal with provisioning, and bucket mutation is a provisioning level concern, I'm actually more convinced now that we should not be doing bucket mutation.
I I still agree in terms of what we should implement,
Hmm.
but I don't see how that gets us out of the what if question that will follow.
No, there is no what if. You can still configure them while creating the bucket, and again, if you want to mutate, we allow it, but from the admin side. That's what we do. We don't allow it from.
No. I mean, yes, we can always say like you do that out of band, right? That's what we do for PVCs.
Yeah.
Right? Like there's a million options you can set in your volumes, and Kubernetes doesn't understand any of them.
Mm-hmm.
Other than like the size and the access mode and the volume mode. Like those are the three that matter.
Mm-hmm.
And then everything else is sort of out of band. So that's a good starting point. But like then along came resize on the PVC, where we're like, oh, okay, now you need to be able to take an existing PVC and change its size, and that means we got to write all these new controllers and all this new logic to deal with that.
Mm-hmm.
And someone is going to ask, like, that will inevitably happen here, where there's at least one thing that you will decide you want to be able to change after the fact.
Mm-hmm.
Fair
enough.
That's what I heard Tim saying, was like, yeah, we can start off with saying no, it's all out of band, but then when the first thing that's not out of band comes along, then
How
we're
do you
right
deal with it?
back to where we started.
Yeah. No, that's a fair concern, and because we don't know at this point what all can come up, it's completely fair to say that. Again, I mean, we would still allow it for the admin to do it. Like we would allow the admin to go ahead and make that change. We just don't have a mechanism to propagate that change to the rest of the buckets, and that's where Jeff's proposal comes in.
Oh, you were going to show us a specific proposal.
Yeah. So Jeff's proposal basically says there'll always be a one-to-one mapping between BR and B, but the BR is only used for greenfield. So there's only one BR and one B, and that BR is, it will be in the user namespace, and that BR can actually go and change or will have the options for, the parameters that go into the bucket. The bucket is still in the global namespace, cluster scoped, and for brownfield, you access the bucket by creating a BAR in the new user namespace for that bucket.
For what bucket?
For whatever bucket was created previously in a different namespace.
But how do you refer to it?
It's the same problem today. You refer to the bucket name is told to you by the admin.
Well, no, I mean, today the workflow is a BR appears in your namespace that's bound to the right B.
Oh, yeah.
And now you have a namespace object in your namespace that you refer to with your BAR.
The idea is the admin is already involved anyways, because the admin has to tell you the bucket class and the bucket access class.
Well, why do they have to tell you the?
So they'll have to tell you the bucket now. So you, as a user, you don't know what the bucket class is or the bucket access class is. You're assuming there's a default, but if there's no default, the admin has to come and tell you.
So I prefer, rather than saying admin, like there is a controller that will do this work for you, right? Like if I have a greenfield BR in one namespace and it does the whole provisioning workflow, out pops a bucket. Now I want to share it with other namespaces. Like I envision that there's some controller at some point which says, okay, I'm going to take it and I'm going to copy it from namespace foo to namespace bar. So if it was created in foo, I'm just going to create another BR namespace bar. I'm using bad example names.
No, that's fine.
They sound like BR. So like the controller could automate the whole process of like duplicating the B with a different
as well.
with the different deletion policy and everything, and it could duplicate the BR into the other namespace, and it could cause them to bind, and it could do this all in a very safe, controlled way, with appropriate access control and appropriate preventions of races and et cetera, et cetera.
No, but we're saying this because you're saying that because because the BAR needs to know the name of the B, and we don't know how the name of the B is going to go into the user users world really. How the user is going to discover this B, correct?
Well, we start from the presumption that, yeah, the user can't see outside his namespace, right? So whatever exists out there is invisible to him. So the idea is you got to give him something that is visible.
Mm-hmm.
And today that's, and if you were in the greenfield namespace, the thing that you would bind your BAR to would be the BR, because you know it, you created it, you picked the name.
Mm-hmm.
So to mirror that pattern in somebody else's namespace, you say, well, you just give them a BR that happens to point to the same thing in some brownfield way, and then their BAR creation process is identical. But you're saying no, like you actually do it differently.
Mm-hmm.
If it's not the original,
Yeah.
you're given some string, and then you just directly refer to it.
Yep. That
Um,
prevents the whole problem of having multiple copies of the bucket. Um, the only problem here, the only reason we didn't go with this approach earlier was because we wanted to avoid the manual step of letting the user know that this is the name of the bucket.
yeah. Boy, I wish I could remember all those discussions from, what was it, 6 months ago?
Yeah. No, I don't think we should go all in on this yet, but this is an alternate in the sense, you know, in case we end up in a situation where we simply cannot move forward. I mean, obviously at that point we can't go and change this whole machinery, but um,
Well, I'm just trying to think through the nitty gritty details. So now we're saying that, like, when creating a BAR,
mm-hmm.
you can either specify the name of the BR in the same namespace or the name of the B in a different namespace.
Well, to be honest,
Or
for
the name
me,
of the non-namespace B, right?
well, if I think so. This is the proposal Jeff made, but one slight change I would make is you always refer to the B. I don't like this two different ways to do the same thing kind of approach.
Well, yeah, I mean, I think it was the aversion to having two different ways that caused us to end up with the original design.
Yeah.
And if we do adopt a design where you can choose either one, then that's a downside to it. But you're saying no, we actually we'll just do this other way always. But then the problem is it's no longer self-service, right? Because now if I create a BR, I can't immediately create a BAR that refers to it.
True, but this is like the PVC and volume mounts kind of situation where
I don't understand.
because they do the matching there, so it works. Okay, never mind. You can't know the name of the PV when you
Right, but you never refer to the PV in your namespace objects. You always refer to the PVC.
and then it does the matching for you.
Yeah, so the whole idea is, like, I can create my pod first and my PVC second, and it's fine.
Yeah, this is one use case that we didn't think of then. How do you do both at the same time?
Yeah. You want to be able to declare your whole set of API objects in one go and not have to wait for any feedback before you can, like, declare another object, because the whole point is your declaration should be internally consistent without any external information.
Yeah.
And
yeah,
yes,
yeah.
if I have to be able to summon up the bucket name, then you have to wait for a bind to occur before you can fill in your BAR. So I feel like at the very least, you're going to have to allow either the bucket if it's a brownfield or the bucket request if it's a greenfield. And then you're going to have to deal with the ugliness of an API object where it's like one or the other, and all of the corner cases that'll introduce.
I'm going down more convolution, but how about something like this? And I'm just thinking this through. We keep it to we say BAR always refers just to the BR, and in order to and there won't be any bucket clones, but there'll be BR clones in whichever namespace you want to go to. So a controller will take the BR from the original namespace and create a new BR in the new namespace wherever it's meant to be shared. So when you create a BR,
but what does that other BR refer to?
That directly has a fixed reference to the original bucket. There's only one bucket instance.
So now you have many to one. Now you're back to many to one binding instead of one to one binding. Right
What
now,
is the
all
problem with many to one again?
the
It's only
problems are
a problem.
legion.
No, no, I'll tell you why I asked that, because it's only a problem if you're doing that matching algorithm. But if you're dynamically provisioning and there's no matching going on, it's not like there are many buckets that many. It's not like PVs and PVCs where PVC can be matched with one bucket, but before or one PV, but before the PV is actually matched back to the PVC, someone else could match to this PV. So that's when it gets tricky, because you have that matching algorithm. But if you don't have that, if you're just doing this provisioning in one way, you don't have this problem.
Again, I can't remember. I wish this was written down somewhere, like all of the reasons why bidirectional binding is so wholesome,
No,
because
I think we give
it's always hard to remember what the benefit is, but
no.
when you
I'll
think
show
about
you
it,
what the problem is. It's actually written down. So volume. So it's here, volume.go. There's this long comment on how this is done, why it's done the way it's done. Plugins, validation util. Yeah. So anyways, wherever that matching algorithm is there, it clearly says that the real problem is with that matching. It's not just, it's not because it's bidirectional, but like bidirectional by itself is not bad. What's bad is the fact that we rely on that to do this matching algorithm, and matching by default, I can tell you, stops it from being declarative. It works most of the times, but it doesn't work
well,
every time.
I'm not convinced. So the proposal is you have a bunch of BRs that all point to the B, but there's no back pointer on the B back to the which BR it was created from.
Yeah.
So
Why do you need the back pointer?
you need the back pointer so that when someone deletes the BR, you know if you should delete the bucket or not.
I mean,
right?
Okay, so is there any other reason? Because if that's the only problem, that's a non-problem, right? Because you can have uh, the main created via the first one be the one that does this. On clones, we mark it as it's a clone. We have a special marker, say an annotation.
Can you change that? I mean, so the whole thing is
make it immutable.
Right, but you need to be able to change it, because if the original does go away and you need to recreate it so that you have a handle to delete the thing, you can construct one. You need to be able to reconstruct one that acts like it was the original one in case you lose the original one.
Okay, that can be done again using a controller.
But I mean, like this was the principle behind having multiple buckets, each with the deletion policy. Is in that case, the deletion policy is the key that says, if the deletion policy is delete, then when you delete the original one, this is supposed to go away. And if it's not, then it's not. And only one in principle should ever have the deletion policy set. But you can override that if you have different ideas. If you want anyone to be able to delete the bucket, you can set them all to true, and you'll get that behavior. Or if you want to be able to switch which one is set to true at any given time, you can mutate one and mutate another one, and always have not always, but you can control who has delete access or not in the model with multiple buckets. My concern here is,
in this model, we're saying that whoever created the bucket is the only one that can delete it, not other namespaces.
I guess, but where is that information stored?
In the status field of a bucket request. The original bucket request will have the status set to original true, and others will have original set to false, and only if original is set to true, you can go delete it. I mean, deletion of that would lead to the deletion of the others.
How would it lead to deletion of the others? Because you'll never find them all, right?
Controller can do it.
But you don't have pointers to all of them.
I mean, if you have a predictable naming scheme, you do have a pointer.
A predictable naming scheme.
Yeah.
Like you'd have to iterate over every BR in every namespace and look for pointers, and
No, you
that's
don't have
racy.
to. Well, no, you don't have to. No. What if the name of each BR that's cloned is actually the name of the original BR dash some UUID.
But you can't control that, right? I mean, an ordinary user can just create one with whatever name he wants and whatever contents he
make it
wants.
collide. You're saying?
Well, I mean, if the semantics are that the mere creation of a BR
Mm-hmm.
with the name of the bucket,
Mm-hmm.
that means anyone who can guess the name of the bucket can just create a reference to it and start accessing it
No,
as if.
we have allowed namespaces in it. We have allowed namespaces in the original BR, and when the controller sees that the original BR has been created with more than one allowed namespace, and then I mean, other than the where it's originally created, then we go and create BRs in that new namespace, and in those namespaces, say the BR names were predictable somehow, then you're good to go.
Right, but what if I want to add another namespace later on? Then what?
You do it. So you're saying if you wanted to add another namespace, you like a brownfield scenario, or are you saying you go and
Yeah. Like, well, what if I didn't know all the namespaces I wanted at creation time, and then over time I want to expand the list with more and more namespaces?
go back to the created BR, the original BR, and go update it there.
So the list of namespaces is on the BR, and then
Mm.
you can just increase it, and then every time you do, some controller will then reflect that object into another namespace.
Mm-hmm.
And then if those guys in those namespaces delete their BRs, it just goes away, and that's
Yeah.
fine.
Yeah.
But then what if they want to get it back?
Add the namespace again.
But it's already there.
What do you mean? Okay, so you what's the scenario again? So you delete it, right?
Yeah, the user who has a copy of the BR deletes his copy,
Mm-hmm.
and then later he says, "Oh, I actually wanted that again. Like, I
Oh,
thought I was done
oh,
with it, but I'm not."
yeah. So the controller knows that it's listening for BR events, so it knows that was taken out. It just goes and creates it. If the user really doesn't want it, then they'll have to talk to the original creator and say remove it from my namespace.
This feels weird. So now somebody in one namespace can just cause objects in other people's namespaces to appear.
And yeah, that's
by,
weird.
by, by merely guessing somebody else's namespace, and then they can't delete it without coming into my namespace
Yeah.
because it just gets recreated every time. Like, that doesn't feel like a great experience in a
In a
situation where.
weird way it is, because what you're saying is this bucket should be accessible from all these other namespaces. So me, I have and this allowed namespace is set in the bucket class again. So whoever the admin is has decided that this should exist on all these namespaces, and this is
Oh no, you just said that the user decided, not the admin,
so
because
the
it's on the
user gets
BR.
to. Oh yeah, because if it's not on the BR, then BC is immutable. Yeah, this is tricky, Ben. This is not something that we can just change all of a sudden. You're right.
So I mean, the thing I liked about the having lots of copies of the B was that, like, over time, as you decide to share it with different people, it's
Mhm.
very obvious what to do to create a new copy and expose it to someone. Like, yeah, you end up with lots of copies of the B, which is the ugly part of it, but every other aspect of it is kind of
Yeah,
nice.
yeah. No,
Um,
I'm on board with you. No, again, this is a very.
furthermore, I want to emphasize, like, this is what we have done with snapshots. Like, when you
Uh-huh.
want to share a snapshot with multiple namespaces, you have to create multiple copies of the volume snapshot content and another copy of the volume snapshot in the other namespace, and then let them bind. And it's just that pattern exists today, and it's, again, it's ugly for the same reasons. Like, having lots of copies of the volume snapshot content that all point to the same snapshot is weird, because if you get the deletion policy wrong on one of them, somebody can delete a snapshot that's in use by another guy. So you have to be very careful about the deletion policy. But, like,
Yeah.
aside from the ugliness of the multiple copies of the object and having to get the deletion policy right,
Mhm.
everything else about it is pretty tolerable.
Yeah.
um,
Agreed.
and I was trying to push the cozy design in that same direction, because it seems like the least of all evils to me.
Agreed. There are two problems here. Again, we really haven't. I mean, I even like again, I don't know 100% sure that this one-to-many mapping is going to be just fine. One, two is again we talked about this allowed namespaces thing. It gets tricky and it gets weird. Yes. So
Maybe we should capture the reasons why many-to-one has problems. So that you said Jeff came up with this and he's not able to join us today.
yeah, he's on jury duty, so
Oh
yeah.
boy, jury duty can take a while. How about
Yeah,
that?
but he assured me that generally they don't like very logical people, so they might.
Well,
Yeah.
I ended up on a jury, and I'm a software guy, and I told them that,
Huh.
so it can happen. You never know.
Oh, really? Huh. Okay. Can you?
I had a 5-day drug trafficking trial a while back.
Wait. When you say you were a part of the trial, were you either the defendant or the?
No, I was a juror.
Okay.
I called me for jury duty, and I ended up listening to the trial and having to come to a verdict.
Okay.
Um,
That's
but
cool. Mm-hmm.
no, I want to capture feedback for Jeff. So the issues with the one-to-many,
Mm-hmm.
from my perspective, are that if you change the set of namespaces that you want to share it with over time, that seems really hard to do. And
Mm-hmm.
the mechanism seems like either you're going to end up in a situation where like people can cause objects to appear in other namespaces that they don't own, which
Mm-hmm.
is a security problem,
Mm-hmm.
or the admin has to get involved. Well, the admin has to get involved in the other situation anyways, but like a controller can kind of automate the process. I can see so many issues with like people just guessing the name of the bucket and then creating an object in their namespace that refers to the bucket and
No,
now having access.
it's still defined by allowed namespaces. Even if they guess it, we're not going to provision the bucket for a workload, and that's not in the allowed namespace. Guessing is not going to get them anywhere.
Right, but okay, yeah, you're right about that. But then if you ever want to share it with a new namespace, I guess you have to change the list of allowed namespaces
Right,
and do
right.
something in that namespace.
Yeah,
And if you and
yeah.
I'm also still worried about the delete. Like, how do you know which event should cause you to actually delete the bucket, and then what do you do with all the dead copies after the original has been deleted? That's
Same
another.
controller that created it takes it out.
But that's a very weird pattern where like
I
some
agree.
controller created stuff across a bunch of namespaces, and then a deletion in somebody else's namespace
Agreed.
causes an object in my namespace to go away. It's
Agreed.
very weird. It's almost better to have just a broken copy where I still have my object, but it doesn't work anymore because the object is gone.
Right.
Which
Makes sense.
is what would happen with a snapshot today. If you cloned a snapshot into another namespace and then someone deleted it out from under you, you would still have your volume snapshot object. You just couldn't use it anymore because snapshot's gone.
True.
And that's not a horrible failure mode from my perspective.
I can get behind that. So you see, I'm bringing this up as the fact that we've been thinking of alternate solutions. Maybe this is not the one that'll work,
Okay.
but if we do end up in a situation where an alternate solution is needed, where we need to be able to mutate some option, I think the best answer we have is the admin can still do it. Go to the bucket objects and directly just do it, and we'll react. The controller will react to whatever the changes are.
I still feel like having a mutation policy flag on the B.
Oh, right.
Would get you there because then an admin could set it once up front,
Mm-hmm.
and then anyone who ever cloned the bucket would have the responsibility of deciding what they wanted to set it to,
Mm-hmm.
and presumably they would set it to false. Usually.
Yeah. I see what you mean. Yes, a bucket mutation policy that says only these buckets or these copies of the buckets can actually mutate. Correct?
Yeah,
Yeah.
and we don't actually have to implement it as long as we don't think we need to mutate buckets.
Exactly.
We can just say that's how we would do it.
Right. So there's a quick way to go from we don't support mutation to we support mutation then.
Yes,
Without changing the architecture.
And I kind of like that.
Yeah, me too. Yeah, I think this is a good discussion. So one of the things I think this kind of concludes it, and I think when on Thursday more people are going to show up, and Tim's going to be here likely, and Boway, and
when are we going to hear about how the network gateway API works?
when Boway joins, likely on Thursday.
On Thursday. Okay.
Yeah, when they do join, I'm going to preface it saying, um, uh, through all these discussions, it's pretty clear to us that mutation policy is not something we should be supporting. But
Right.
in case mutation policy is something that mutation is something that's absolutely needed for a new field that we completely didn't anticipate, we do have an answer.
But I think the case Tim and whoever else is going to join is going to make is that they're going to say we don't need any non-namespaced objects. I think that's the argument they're going to make.
Right. I'm aware.
They're going to say all this stuff can be namespaced and that's better.
Mm-hmm.
And I am very eager to hear that argument because I've never heard it.
Well, yeah, no, I think they're not just saying that, Ben. They're saying that we're going to have like a cluster role and a role binding, or cluster role binding and a role binding. We're going to have both namespace and non-namespaced. That's what they're going towards.
What do you mean?
So we're going to have a bucket request and bucket namespace, and then we're going to have a cluster bucket request and a cluster bucket non-namespace. That's what they're going towards, if I understand correctly.
Oh. And then a cluster bucket would be the brownfield solution.
Mm-hmm.
Well, that's totally, I mean, if that's what they're proposing and we like it, then that's a huge deviation from the current plan, right?
That's too much of a deviation, yes, but
no, I'm not saying it's too much. I'm just saying we better find out about that soon and start changing our plans if that's actually the right answer, because it's going to be a huge amount of work.
Yeah, but again, how can that possibly be the right answer? Because again, the requirements haven't changed.
Well, boy, I've got a meeting in 3 minutes. But the thing I find appealing about that proposal is you could say, okay, greenfield buckets are always namespace buckets,
Mm-hmm.
and brownfield ones are always cluster buckets.
Mm-hmm.
And maybe there's a way.
How does a user discover a clustered bucket, and how do they go from discover?
How do you? I don't know about the discovery aspect of it. That's an interesting question. But like, I could see that, if for workloads where you never ever needed to share, you could just create buckets in your own namespace and use them in your own namespace and be happy forever,
Mm-hmm.
never sharing.
Mm-hmm.
And then for ones where you did need to share,
Mm-hmm.
you would either force people to create it outside of the cluster and then use the cluster bucket mechanism, whatever that ends up looking like. I'm curious about it. Or you'd have a way to promote maybe a namespace bucket to a cluster bucket through some process. To make it shareable, if you wanted to do that.
Mm-hmm. My stance is still this, Ben. I don't think bucket mutation is important, and I don't see a good reason why that would be. I don't want to change the requirement because we have a different solution. That's
I just it's something I hadn't considered, so I'll have to think about that one.
Yeah. And also it's new, right? We don't know what are the problems that they will introduce, right?
Yeah. I'm sure it'll have a different class of drawbacks.
Yeah, definitely.
But given that Tim is like our API god, I'm want to listen to his
yeah, we definitely want to hear.
Of course, yeah, of course.
But likely there are things that we won't discover until that gets into like a beta or GA stage.
We've had a lot of
design, right?
Yeah.
Time.
Yeah. Anyways, I think this is a good discussion. There was one other concern I wanted to bring up, that is provisional registration. We never talked about having an API for that, API object for that. Some like CSI has the concept of a CSI driver and CSI node. We don't have something similar for buckets. So I had a proposal here. We don't have time today, but I'll bring it up on Thursday if we have time.
Well, but the only reason we did that in CSI is like so that you could set Kubernetes specific flags on your CSI plugin that couldn't be detected through the CSI spec itself. I think the earliest versions of CSI didn't have those because everything could be detected through CSI. And then they realized, oh, we want to have some Kubernetes specific special sauce on top of CSI, and this is where we're going to put it.
CSI drivers are auto-generated. So, I mean, like the user isn't going to make any changes there.
No. They're created by the vendor when it's installed.
No. The CSI container, the CSI provisioner, which is the SDK or it's the sidecar, goes and creates it.
Yeah,
It's not done by the vendor.
So,
One of them is created by the vendor. There might be two of them. But
no, nothing's created by the vendor. Vendor doesn't even know there's something called the CSI driver or CSI node.
Yeah, they do.
no,
I
it's
have
actually it's the driver.
I have 3 CSI drivers, and I do this manually.
It's driver's responsibility. Yeah. Okay. So
I mean, it's auto-generated. Yeah. Anyways, it's out of time. One more reason for provisioner is so that we make sure there are no two provisioners registered by the same name. Stuff like that. Again, we can discuss on Thursday. Not something.
That's a non-concern. We just tell people, like, if you ever have collisions in your provisioner names, all bets are off. Like that's a non thing to worry about. Like,
well, yeah, we'll talk about it on Thursday. Yeah,
yeah.
Yeah, I just want to hear more about that. Yeah.